We're gonna do a quick little carb clean on this thing since it stinks. And we already got it off. Yeah. What is that? Huh, he said it ran, but that's a clogged pilot. Totally clogged. And I have no wrenches or pliers in here. Look at that. Well, let's see how many turns this is. Okay. So 0. 0 turns. We're going to put a little bit of this stuff on this gasket because this stuff is gas resistant, whereas most RTV is not. So we got some little spots where it's kind of flaked up, coming apart a little bit. So now we have this set to 2.5 turns out. And it's fully reassembled. Alright, we got some stuff. Here's like our order of operations. That other fan didn't work. Fan, motor mount. This might get shifted this side. Temperature sensor for that. Brakes. Got 2 lines. Both of these lines are they're too long for either the front or the back. The back were ripped. This was a kit for the front, but they're too long. So we'll probably use them for the back and put a curl in them or something. Got a lift bed cylinder. And then, of course, gotta get the engine in. So I got this primed up to test it. And oh, I thought I did. Thought I had it primed up. So that one works. Check that out. And they ran this brake line. They ran it through the bracket for this fan. So now I got to try to take it off up here, or cut the bracket, or remove the brake line, which it's actually technically removed, but it's like bolted in here and zip tied and a whole bunch of shenanigans, and it's got the 4x4 wires in it, at least one of them, the one that's not broke. So yeah, what the frick. I chose violence. This one's been crimped and T-tapped into something else, so we'll have to chop this off, and we'll just use one of those crimpless butt connectors. I don't know if I showed this already, but the old fan, probably why it was burned up, it had hit this coil wire for the spark plug, and it was like lodged against these throttle cables, and so this is what it did to the coil wire. It nicked it, but there's no strands broken. So what I'm going to do is blast it with some brake fluid, and then we're going to fill it with some black RTV. Call that as good as anyone can get it. Typical Chinese production quality. These holes are too small for these bolts for the intake boot. So, I'm gonna do some drilling now. Okay, that took about half a second to figure out. We just put a zip tie over here and it's way out of the way now, so. If I'm not a rocket scientist, what's it say about the last guy? Well, we are at the stage of trying to get all the oil system hooked up. Got some new line ran. It's down there. I got a hose clamp on that end. And as I was trying to adjust it, I realized that there wasn't enough adjustment, which explains why they bypassed it. And it takes a long time to get that stuff dirty. That's probably factory fluid in it. And just from the smell, I can tell it's that purple stuff. That stuff's got a distinct smell. Look at that. That was a lot on there. Alright, I'm testing this new temperature sensor before I put it on. That one's a little hot still. They look a little bit different. But basically this thing, it's kind of like a thermostat, I assume. It's got like a spring in there that once it gets hot, it closes the circuit. So we should be able to get this thing hot, and then when it gets hot enough, it'll beep. And we don't want to melt anything, so we'll just put a little heat on it like that and let it soak in, and there you go. It's beeping. So that would mean that's to tell the fan to kick on, basically. And then once it cools down, it will open the circuit back up. Just like that. Here's the next dumb problem that shouldn't exist. The thread length. So that's not even enough to go through that thick steel plate. You put it through that thick steel plate and it's got like one thread sticking out. So we're going to have to make a plate to hang off the other plate to mount this to that plate. Alright, there's the magic piece. So there's what it's looking like. Alright, this is supposed to take half a quart. But since it's expensive, well, so expensive that they can't even put like a looking glass through it. You just have to kind of guess. We'll just check it periodically. I decided to just blow a little air in here. I had it opened up for like a week. Just blow the dust out that settled, but a whole bunch of water came out. I got a towel in here. Just throw that in there and let that soak that up. Blow some air around in there. You can see it dripping out of here. You're doing a good job. That one's not quite as girthy, is it? But she's, oh man, she's stout. This one's like an actual shock absorber, and it's got, you know, an eyelet and like a bushing spacer in there. And it kind of needs that spacer, so this is what we're going to use for a spacer. Looks too good. One thing we're going to do over here too is we're going to lap this surface too, because this one doesn't even have a keyway. And remember, we noticed that this was different right here, and that top cover didn't even have a bolt holding it in right there. Well, yeah, now look at this. We got these two are at an angle, and these two are straight up and down. Let's see if we can fish it through like this. Fish it through from the back side. So I think what we're going to do is we're going to get the Dremel, and I'm just going to turn this circle into an oval. That way I have room to put it in at a sharper angle. Yeah, you can't get backed out now, can you? I'm gonna put some of this stuff on here. It's wicking thread locker, so I already got it on there tight, and I don't want to take it loose. It'll seep into the threads. All right, perfect. I can see this squishing through everywhere except this the end of the crack. We're running out of room because this is thick down here and real thin up here. So these are not gonna fit much longer. Yeah, see, that's already. We might be able to keep using these. I want to cut them off like inside of the plastic, because if you cut them off flush when you go to put that boot on, wherever that boot went, it's going to poke into the boot. So you don't want it poking into the boot. Old kerosene. Man, that's looking like a brand new filter, isn't it? I put that on eBay. OEM. Open box. Don't worry about the seeds. It came straight from Canada. We'll let that drip dry in here. The new belt is a Kimimo Tohafo. Driving two-wheel high for 20 minutes between 25 and 45 and in flat terrain, not on flat terrain, in flat terrain, avoiding hard acceleration in hills. Shift the belt through the normal operational range by varying speed and engine RPM, but do not exceed 3/4 throttle. Well, this thing to get to 25 probably needs 3/4 throttle. And it doesn't have two-wheel drive. We can't even break this in properly. Let's see what this is going to be about. It smells like mouse piss. You know what I need to do? I need to check to see if these 3 washers are supposed to be on there. So there's probably some special tool, maybe even some special method to changing this belt. Man, the fresh belt hurts my hand. But what I'm gonna do is just compress this the same way I did earlier. Like that. And then just keep that compressed on there. I need a little bit more. Keep some pressure on this side. Slip that on there. Put this on here. Like that. And I looked that up, and it said that there was 1 bushing. It didn't say 3, but it had 3 on there. And if you look, if you draw a straight line from like the center of this to the center of that, is generally how you get an idea of if you need to shim your secondary. That looks good because it's basically, you know, barely kissing this back side, and the front side's not touching because it's waiting for, you know, engagement from RPM like that. So that's what you'd want. So I'm gonna leave those 3 on there. It's like the first thing I think I've seen that somebody did right on this thing. All right, that one's supposed to be 40 and that one's supposed to be 18. So I got this in gear and I got this set to 20. There's 20. 20 feels weak. I had just a little bit more on 20. And then for this one, this does about 40 to 50, which is perfect. Let's get one of these I haven't spray painted black and turned into an impact yet. What's that? 5/8. Yikes. Well, that's just great. Jeez. Got a better look at these guys now. So there is what we got going on. So we're just going to put it up in there like that and then probably do a little loop-de-loo. So our 4 new calipers, even though they're the same brand, 2 of them have like these really yellow gold pads, and these have like gold bronze pads, and then this floating plate, mounting plate, is like a different material. You want to mount it to where the bleeder is the highest point, because if I were to mount it like that, then it'd get air trapped up in here. You'd never be able to bleed it. So this one needs to go on that side. What the fuck? Oh, shoo! I got my foot stuck. Foot's stuck. I use my foot up in here to push on that. Now I got it like locked in here. Oh man, that was awful. So yeah, I had to use my foot to push on that to basically bend the other spring to close the gap. Oh my god. Oh, thanks Polaris. Well, we need to take the hub off to get to the bolts for the rotors. We're doing rotors and calipers on the fronts. But while I'm in here, I want to figure out why the 6x6 isn't working. It's got this switch. It's held on by a broken zip tie. And it doesn't matter which way you flip it with the key on and in gear. This one that doesn't have the broken wires, it still doesn't engage and lock in, and that's done off of a magnet. So when we pull this apart, we're going to be inspecting this, and we're going to try to look some stuff up and see if this is supposed to send 12 volts or whatnot. I can tell you that that is some tiny wire right there, and I did see these tiny wires right here, brown and gray, which are actually like stretched really tight. I'm not sure why they're stretched so tight, but that might explain why they're not working. They're probably unplugged. So we're going to try to figure all that out. I don't think them have came off in a long time. And then there is, it looks like a set screw, but that's the fill hole. We'll figure out what these take. The ones I did in the past were ATF type F. Let's poke into these wires real quick and see if we can figure something out before we disturb anything. Let's poke into, I don't even know if I'm in, I poked into this wire before the connection. Maybe I ought to just take and poke into this big wire, since I know it'll actually poke it. Yep. So there we go, 11.7. So it's sending the voltage. What I want to do as well, though, while I'm down here jabbing holes into wires, is let's poke this other one and let's check it for continuity, because this one should be the ground and we're grounded here, so this should beep when I turn this. Good. Okay, so that tells me that the magnet in here, and those magnets allegedly are picky about the amount of fluid that's in them. So if they're not filled up properly, they won't work. So that alone could be it, but we're going to be peeling that off to get to that rotor anyway. You ever seen anyone do this? Has anyone ever oiled daily? It looks clean in there. Let that drip for a second. So right in here, this gap right there, there's a magnet. And that magnet is supposed to suck this ring. It's got these little notches on it. It's supposed to pull that back and keep that like this. And then locks these in on this little stop sign looking piece. And then when that's on there, it doesn't allow this to push out to where it locks it in. So we'll try to figure out what the deal with that magnet is real quick. Pull that out as a unit. Got a taper bearing. Oh, a Timken. Fancy. Let's turn this on. And then turn that off. Still got a little bit of magnetism. Now let's turn it on. Okay, so now that's like locked in. That's sucked on there good. I can't peel that off now. So that's working. That's working, but why wasn't it working? That's what we need to figure out. And all that is just another taper bearing on the inner. So there's nothing else to really take apart. So we're going to put that back on there. I think what we're going to do is we're just going to refill it to the proper level and then just see if it works. Since this was already basically clean, we're not going to hose this with brake cleaner, particularly because of this seal, which didn't look like it was leaking based on the dirt. We're just going to use like some WD-40 and some air. Oh, sliding this off. Sure, didn't get that dirty again. And then the next taper bearing. The notched washer. And our nut. I don't think all that's on there all the way yet. So we better double check to make sure that that little plate, the fingers in that plate, lined up, because if they didn't, yeah, see like that? I would have just cranked that torque wrench on there, it would have folded them fingers up. Bad stuff would have happened. All right, so typical taper bearing torque is do it by hand, which is contrary. If we search for Big Boss 250 6x6 front hub torque spec, AI says torque the axle to 120 foot-pounds. Okay, AI, you need to go back to the matrix. So yeah, I don't know why we're doing inch pounds. It says to do, this one says 60 to 80 inch pounds. This one says 160 to 70 and then back off. And this is a 3/4 inch socket, so I got 2 different adapters on there. Imagine like any taper bearing, if you get it too tight, it is not going to turn. Which, speaking of turning, we need this knot to turn. Let's see if we can get this just to jam up like that. So I got this at like 15 foot-pounds. All right, so that's tight. It doesn't want to spin freely. So then let's back off a little bit. Let's back off more. Let's see if it just gets like substantially easier. Yeah, so that's not even tight anymore, which means that this amount of drag is the minimal amount of drag. So then we're going to tighten it until we maintain that minimal amount of drag. So there, it's getting a little tougher. And then let's see, as far as our mark, we're just like a hair past where it used to be. Which probably makes sense, right? From a little bit of wear. Man, AI is just worthless. Big Boss 250 6x6 front hub fluid type. For a Big Boss 250 6x6, the recommended fluid for the front hubs is typically a medium weight gear oil like 70W90. That's wrong. Like, I know that's wrong. Absolutely wrong. I knew that was wrong before I even read it. Polaris always has their proprietary nonsense, the on-demand fluid or whatever. And then pretty much all these styles with the magnet do the type F. AI is like a scam ad that pops up on every single thing. So this sounds right. Fill it with fluid, and then you turn it to the 4 or 8 o'clock position, and then let it run out. And this one's saying 3 and 9. Oh, it's freaking internet. Click one thing, it says 4 o'clock. Click another, it says 3 o'clock. The more of like the manual style stuff though, I'm seeing 4 o'clock. So I don't even know how much to start with in here. Oh, well. Alright, well I guess you need the cap on. That'd make sense, right? I knew what I was doing. I needed a little bit to put on these O-rings, so. And that was just a fancier way of doing it. All right, do we think that that's 4 o'clock? I bet you that's more like a 330. Okay, let's maybe spin that around a couple times. I still got the key on, just running the battery down. And it did not lock in. That upper shock bushing, strut bushing is it's gone. All right, we got the same test over here on the broken side. And so that confirms that this wire is hot. That wire is ground, and it is. So then all we need to do is connect these two together. I see a spark. Good thing and bad thing. Just lightly twist these together for now, and we're gonna see if this magnet does magnet things. And it does. So that means the magnet portion of it's working. We got a busted nut, boys. I have a theory as to why they ran this through here when we were changing this fan out, and I chopped that off because this is just barely not long enough to get in there at a square angle to tighten that down. And if we follow this through, you can see this distribution block right here. It's not mounted or anything. I feel like it should be up in here to give me some room. Oh, got hillbillied again. So I loosened the left side mounts on the fan to where I could pull that in between them. Give me more slack here. This was pinched too tight, so I had to take the bolt out of the strut here. Shift this around, but I got that on there now. Alright, I think I figured out the 4x4, so we're free spinning right now. And we flip the switch. We're still free spinning, right? But if we put some resistance on this with the axle, which way? There we go. Now it's turning everything. So it needs some kind of resistance to make it work. See, this one's locked in now. So that's all it was. It just needed, you know, something, basically, because the chain's unhooked right now over there, because we're still messing with this side. So if this was hooked up, then this and all of this would, you know, be kind of fighting each other if, you know, you were actually on terrain, and then that would be enough to lock this stuff in. So it works. And I found out what this little clip is for too. It's definitely for this. I just got to figure out how to finagle this thing on here. Okay, that was dumb. That is a dumb design. Try to button up some of these 4x4 wires, taped them up to the brake line, and then zip tied them to the strap that way. Nothing's moving around. We're going to go ahead and throw the wheels on there for now. We're still missing the master cylinder. It's on order, so can't bleed them right now. All right, we got these bleeders cracked down here. We got some non-brake fluid approved lines hooked to them to just drain into a container. I can't fit that in there. This thing actually has garbage ground clearance. And what the hell is that? And we're just gonna gravity bleed these. So we're just gonna pour some brake fluid in here. And wait till it comes out there. That's pretty much it. Alright, so we decided to put that little phone charger right here-ish. The other side's got too many wires and stuff going on. So, let's see. So right about here. Let's see, right about there. Yeah, right about there look good. We're going to take a measurement so I can do a little scratch on that. So that is 3.5. So we need one. No, we don't want it right in the center because I'm taking that measurement from here. So let's do it from there. 3.25. So that put us at. Is that 3.25? Yeah, 3.25. So that'll put us at 1 and what is that? 5/8. Whatever, that looks good enough. And then as far as that being centered, it's not quite centered, but that's where we need it to be because stuff in the way. So I'm gonna do a pilot hole with this. This has this look to it. There's like 1,000 little tiny cracks in this thing. I know the bit for my hole saw's dull from doing things with it that I shouldn't have. Nice and straight. Lovely. Perfect. And I already have some wire made up. This is allegedly 3 amp. So 6 amps. It could be done over 18 gauge, and this is like 14 or something. And what we're gonna do is we're gonna plug in to these bus bars that are already here. We just need to find a place to plug it in. I know ground is over here on this side, and what we need to do is find a switched ignition. So let's get a ground going. And this looks pretty open right here. So let's see if that's hot. That's hot with no key, so we don't want that. How about this one up here? Perfect. I don't know. Here, sorry. You can't see nothing, can you? All right. So we're gonna do that. Key off, dead. So that little guy right there is where we're gonna put one of them. Let's see if I can just squeeze. Can I scooch? Can I scooch in there? Okay, so there's that one. There's our hot. And can we just shove that through there? Look at that. Just shove that through there. We'll put a piece of black tape on this one, just like a real electrician, to let everyone know it's hot. Everything on this is definitely up to code. I like it. I actually like that. It's flush. It's not too obnoxious. Cool.